This lesson is for Advanced Algebra, Lesson 2.9 on combined and joint variation. We're going to start just by going ahead and defining those words right away. Joint variation, which I took the definition straight out of the glossary in the back of your textbook, is simply a situation in which one quantity varies directly as a product of two or more independent variables, and there's no inverse involved. So this is basically a direct situation with multiple variables. So you can see here the formula for area, I think it's area of a pyramid, is 1/3 pi r squared h. So there are two independent variables here, the radius and the height. So this would be considered direct, going on multiple times. So we would consider this a jointly varying set of variables. For combined variation, that's a situation in which we have a combination of both direct and inverse variation occurring together. Keep in mind there could also be more than one of each of those, but as long as there is one of each, that would be considered combined. So for that one we have this example. M varies directly with its width w and the square of its thickness t, and inversely with the distance d between the supports. So if we were to write a equation that would match that, remember that the first variable listed is your dependent, and then directly with its width, so we would need to say kw. The directly here goes with the word and, so we say directly with its width and the square of its thickness t. So the w and the t need to get multiplied by k. Don't forget to square the t. And then inversely with the d, so we need to divide all of those by d. So now because we have direct and inverse occurring together, we would call that a combined variation situation. So we're just going to do a bunch more of examples here, and then we'll label them as we go. Next example. The volume of a solid with a circular base varies jointly as the height of the solid and the square of the radius of the base. So this one we just need to choose some variables as we go. So the volume is listed first, so I'm just going to simply call that V. And it varies jointly, so that means I know that I've got multiple direct variables going on, as the height of the solid, so I'm going to say K times H, and the square of the radius. That's also going to be direct, so I say times r squared. Keep in mind that the order of the variables doesn't matter, and if you choose other variables, that's also okay. So either one of those would be appropriate. Next example. The time t that it takes a parade to pass a reviewing stand, kind of like bleachers, varies directly as the length L of the parade and inversely as the speed S of the parade. Write a general equation to model the situation. So again, our first variable listed is t for time, and that is going to be our dependent variable. And then it varies directly, so I know it's going to be k times something, and in this case it's k times L. Inversely is also mentioned, so I know that this is a combined situation, and so I need to divide by something as well. So inversely as the speed S of the parade. So this time they do give us the variables, and so we want to make sure to use their variables and put them in the correct location. In our last example here, we're going to write the equation, again based on what they say. A baseball pitcher's earned run average, or ERA, varies directly as the number of earned runs allowed and inversely as the number of innings pitched. Write a general equation to model the situation. Just be careful here when you're doing ERA, you don't want to use 3 letters to establish that, you want to just pick a single letter. So I'm simply going to call the ERA just the E. So I'm going to say E equals, and it says directly as the number of earned runs. So I'm going to say KR, and the earned runs I'm going to label as R. Inversely as the number of innings pitched. So I'm going to call that P. It is inverse, so I need to divide by the P. Now I'm going to utilize that equation to find a value for K and answer the question. In a recent year, a pitcher had an ERA of 2.56, having given up 72 earned runs in 253 innings. How many earned runs would the pitcher have given up if he had pitched 300 innings, assuming that his ERA remained the same? So we're going to plug some numbers into the original equation we wrote. We're going to solve for K, and then we're going to plug in the values to solve the question. So ERA was 256, and remember ERA I've labeled as E. Then the K I don't know. The earned runs was 72, and the innings pitched was 253. Upon further evaluation here, I might want to modify my equation, and since it talks about the number of innings, I might want to change that P to an I just to make it match a little bit better, but it really doesn't matter. Now if we're going to solve this for K, you've got two options. You can multiply by 253 on both sides and then divide by 72, or you can simply multiply by the reciprocal of that fraction. And that's faster, so that's what I'm going to do. I'm going to multiply by 253 over 72. And when I go ahead and multiply that, it's about 8.99, so I'm going to round that off to about 9 for K. So now let's utilize that into our original equation of E equals 9R over, and now I'm going to, well, we'll leave it as P, but I guess we could have also changed it to I. And now let's fill in the remaining numbers. They tell us that the earned run average remains the same at 256. We don't know the R, and we know the innings is 300. Again, here you've got the option to multiply by 300 and then divide by 9, or simply multiply by the reciprocal. So I'm going to go ahead and do the reciprocal here. And then I'm going to go ahead and calculate. And I get about 85 here. I did round that, so I do want to go ahead and use an approximately equal to symbol. So we'd say about 85 earned runs. There is a question here in the homework that I'd like students to try. Go ahead and pause the video, and then I'll reveal the answer here shortly. So I went ahead and used the formula, plugged in the numbers, and I got a value of K of 3.4. And so I decided that Sonia did not use the correct formula because if you look at the formula for volume, typically if it's got a cylindrical base, it's going to have the number pi in it, which is 3.14, not 3.4. So I think her formula was off, or maybe she just mistyped the calculation there. That should be 3.14.